This may be the most famous equation ever written, E equals mc². You've seen it in textbooks, posters, and even t-shirts, but behind its simple appearance lies one of the deepest ideas in all of science, an idea that changed how we understand matter, energy, and the universe itself. This equation emerged in 1905, during a period when physics was undergoing a profound transformation. While developing his theory of special relativity, Albert Einstein discovered that space and time were not absolute, and that mass and energy were deeply connected. E equals mc² expressed this radical new view of nature in a remarkably simple form. This equation breaks down into three simple parts. E stands for energy, m stands for mass, and c is the speed of light. What the diagram shows is that mass can be thought of as stored energy, with the speed of light squared acting as the conversion factor that links the two. The speed of light is about 300 million meters per second. When squared, it becomes a gigantic number, explaining why even a tiny amount of mass can correspond to an enormous amount of energy. According to E equals mc², mass and energy are interchangeable forms of the same thing. In everyday life, this energy remains hidden, locked inside matter, and completely unnoticeable. Only under extreme conditions, such as inside stars or nuclear reactions, does that stored energy reveal itself. At the core of the Sun, hydrogen nuclei fuse together to form helium. The helium produced has slightly less mass than the original hydrogen, and that mass is converted into energy, as described by E equals mc². That energy flows outward from the core and eventually reaches us as sunlight. The mass-energy relationship described by E equals mc² has important human applications. In nuclear power plants, small amounts of mass are converted into energy to produce electricity. In medicine, technologies such as PET scans rely on mass-energy conversion to image processes inside the human body. And in scientific research, particle accelerators use this principle to probe the fundamental structure of matter. Einstein's equation showed that mass and energy are not separate quantities, but two forms of the same physical reality. It reshaped our understanding of conservation laws, revealing that mass can be converted into enormous amounts of energy under the right conditions. This single idea became a cornerstone of modern physics, influencing everything from nuclear power and particle physics to our understanding of stars and the universe itself. Einstein's equation is still essential to modern science and technology. It underpins our understanding of how stars shine and how the universe evolves, guides particle physics experiments, and explains how nuclear energy is released. From power generation to everyday technology, E equals mc² continues to shape the world we live in. Thank you for watching.